Welcome everybody to our virtual meetup. So my name is Chris. I'm a senior support engineer here at Elastic. I'm in the company since about 1.5 years, and I'm going to talk a little bit how to set up and run your cluster, a couple of tips and tricks. I hope you like it. So the first thing is what support. So we are a distributed team. We are about 130 people working in 18 different time zones, speaking more than 15 different languages, and in probably now more than 25 countries. So we work around the globe and around the clock to provide service to our users. And this is a picture of our last meeting last year. Not everybody is there, but it's already a big team. So the main takeaways from this presentation are there's no one size fits all. The way you're going to configure your environment for one case will depend on your use case, on the resources you have, and if you change your use case, you're going to have to configure it different. So everything depends, as we usually say here at Elastic. So there is no silver bullet on that. We're going to talk a little. So what's the stack? So we have the Elastic stack. The core of it is Elasticsearch. Where the data is stored, you search, you analyze the data, you have a visualization layer with Kibana, you have an ingestion layer with bits and Logstash, and on top of that, we build solutions. You can have this in our cloud offering, you can have it in your own clouds or when you're on premises, orchestrator or not, standalone as you want. I'm going to today focus on Elasticsearch itself. That has a ton of little things that we can configure. So what are the types of licenses that we have? So we have the open source license, which you go download the open source version, you can do whatever you want with it. We have the basic license that is the open source plus free proprietary features. And we have the paid licenses, each one with some set of features that comes with support. And we move things from time to time from the paid to the basic license, like we recently did with security. And all levels, it was something that the community has been asking for a while, so it made sense. And we usually don't, as far as I know, we don't move things away from the basic license. But so you can have either these set up of on-prem licenses, or you can have the paid license inside our Elasticsearch service, formerly known as Elastic Cloud. And as I said, in the paid version, you get the amazing Elastic support. Yay! So the channels of communications that we have here are the Discuss forum, where you get a team of highly qualified people answering your questions there. Developers, support engineers, everybody's there. But you don't get SLAs associated to it. So when you ask a question, you might get an answer quickly enough. It might take one day, it might take a couple of days, eventually a couple of weeks. And for the paid live subscriptions, you have the support portal where you basically have pretty much the same team of people, but answering the things under an SLA. That will go from 1 hour to a couple of days, depending on the severity of your question. So how do you deploy Elasticsearch? You can do it bare metal, which is the simplest way to run Elastic. You get your machines there, you install the nodes, you run them, and this is it. You can have a virtual environment that maybe is simple to run and maintain, but allows for dynamic growth of your system. So if you need more nodes, just spin new VMs, put your nodes there, or if you need more memory, just reconfigure your VM. You don't have to recommission things as long as you have the capacity. Or you can do it with containers. Elastic provides official Docker images. It's very flexible, it's very powerful, but requires knowledge. So you need to be proficient in containers to run the thing properly. Or you can run in our SaaS offering, where you can spin deployments there in a matter of minutes, configure what you have there, scale up and down with sliders and buttons. And it's really nice. And the graphic interface now looks really good. But what do we do in terms of setting up? So the first thing, it needs to make sense. Whatever you do, it needs to make sense. You don't do the things because they look cool. Elasticsearch is very easy to install. You can have a node running in your laptop in less than 5 minutes. And this comes, it's a blessing and a curse because everybody thinks everything is going to be very easy afterwards. Have you ever tried to install an Oracle database or a Sybase database? You know what hard to install means. Elasticsearch is very easy, but to run the thing properly, to run a cluster correctly, first you should not take it as a black box. You should understand what's happening there. You should understand how Elasticsearch works, how is Elasticsearch built, and what are the points that you need to pay attention to. And that requires effort, and that requires that you acquire knowledge. So we suggest you go to training. We have webinars, we have free training, there's videos on YouTube explaining, but understand how Elasticsearch works. It's important to get the production environment up and running correctly. That gives you the performance that you expect. So don't take the things for granted. Size it properly. No overcommitting, no over allocating. There's no magic there. You're not going to get a couple of small nodes and make it run as a very efficient cluster. You need hardware, you need a network, you need disks, you need the proper equipment to make the thing work. And more important than anything, I suggest you build for flexibility. So the stack evolves too fast. Don't build your stack in a way that you cannot scale it, and don't build your stack in a way that you cannot upgrade it. So don't get stuck on older versions, because we release lots of new features, lots of interesting features on every release, and make use of it. Like, don't get left behind, and upgrade as fast as you can and as often as you can, because the more you wait to upgrade, the more complicated it gets. Especially if you have logging use cases, for example, where your data evolves, then it's really interesting to keep yourself up to date. A couple of pro tips here. Maximum, so Elasticsearch is a Java application. So those that doesn't know that. So it runs in the JVM, and the JVM has a chunk of memory allocated to it as heap memory. Don't make it larger than 30.5 gigabytes. That not to break the compressed ordinary object pointers. So when you go beyond that point, the JVM can no longer use compressed pointers. So actually you go a little bit above that and your performance drops dramatically. You will eventually reach a point where you will overcome that issue of the compressed pointers, but your heap is going to be, I think it's around 46 or 48 gigabytes, where you recover performance. But then you have a huge heap. Garbage collection will take a very long time, and while you're running the garbage collection, your node will be stopped, will not respond, and you don't want that to happen, even if it happens once a day or once a couple of days, because of the size of the heap. And maximum size of the heap, not more than 50% of the machines run. Elasticsearch still needs the operating system to work. We still use file cache, we still use file descriptors, we still use the OS. So the OS has to run, and for that, it needs at least 50% of the RAM available. And use fast disks. The SSDs are really awesome. Performance for fetching data and for storing data on disk. If you compare spinning disks with SSDs, it's like you won't even think about it. So if you are using slow disks, performance will drop. Be aware of that. If you can use SSDs, great. What is the natural evolution of the stack? What do we see in our users? What happens? So there's a department, and they decide to make a project, and they need Elasticsearch for that. They decide Elasticsearch is the technology they want for that. They install this, it works, and this project gets famous. So everybody now wants a piece of Elasticsearch. Oh, we also have a use case for that. And your cluster will start receiving more data and more use cases. And you're going to have to scale your cluster. you get more nodes, and you get more data, more requirements, more tenants, and conflicting requirements because somebody wants very fast ingestion, somebody wants very fast queries, somebody wants this, somebody wants that, and you not always can put those things together. So you have a bigger cluster. So what happens, bigger clusters not that easy to manage. So you decide to split your cluster in smaller clusters per tenant or per use case or per department or per project or whatever. Then, okay, each single cluster is again easy to manage, but you have many of them. And that's the point where you evolve to orchestrate a solution like ECE or ECK, where you have big allocators, you install this orchestrating platform on top, and then you spin your clusters inside, and you have basically what we see in Elasticsearch service, that you can control your clusters, scale them up and down very easily. So this is usually how we see it evolving. The core of Elasticsearch is the shard. Shard is a Lucene instance. Lucene is the heart of Elasticsearch. How many shards do you need? That comes the terrible answer, which is you need as many as you need. So not more and not less than that. If you have too many shards, each shard has metadata that lives in the heap and will start eating the heap. So we talk about a maximum of 20 shards per gigabyte of heap. This has changed now recently with the release of 7.7, but we still don't have the numbers for that, but it has improved a lot. But if you're not yet in 7.7, 20 shards per gigabyte of heap is like your upper limit. You will start seeing performance decrease even below that level. So you don't want to have too many shards, but you have a certain amount of data. So put the data in as few shards as you can. We say that shards work very well between 20 and 50 gigabytes of size, but you need to have enough shards to have enough search throughput, so be able to parallelize. If all your data is in a single shard and each shard has 300 gigabytes, you're still going to search in a single thread. But if you have 10 different shards, you'll be able to parallelize that in your nodes. And also keep in mind that usually you don't search in a single index. So if you have daily indices, you're not going to search in a single day. Or if you're going to search in a single day, you're going to have a small amount of data anyway. So you're going to search in 30 days. So you're going to have, if you have one shard per index, you're going to have 30 shards, and that's enough to parallelize your search. And by search, also your dashboards, your visualizations in Kibana and everything. Index lifecycle management is your best friend for that. So ILM will allow you to manage your shards. We released that recently, well, 6.7, so it's been a while already. We're already in 7.7. So I'm going to talk a little bit about that later. And we have this webinar about sizing and capacity planning that's worth watching if you're planning to make a new cluster, or if you want to review how you made your cluster. It's really worth watching that. The cluster size, so it evolves, as we see, in time with use cases and with data. You usually start with 3 nodes where all your nodes have all the rows. So they are master nodes, they are data nodes, and they are ingest nodes. Then you grow that to 10 nodes. Around 10 nodes, I would start thinking about having dedicated master nodes, because the cluster state becomes something a little bit more complicated to handle, and the data and the ingestion rows also. And you might get up to 100 nodes or so. There's no limit on that. But I suggest that before you get to 100 nodes, split your cluster. That's probably the best thing to do, because 100 nodes is pretty hard to manage. Imagine anything you do there, if it takes 2 minutes, it would take 200 minutes to do whatever you have to do on each node if you do it like a rolling restart or something. Then you can get to very large architectures. And this thing must make sense. As I was saying, don't do the things because they look cool. Do the things because you need to do it. Yeah, a hot, warm architecture. Yes, I can do this. Look at that. Oh, the shards move from one side to the other. Do you have different hardware? Do you have a very fast hardware to make a hot architecture? Maybe not. So yeah, or do your data really fades out and you don't search your data after a certain point except for special occasions? Then it starts making sense. So you can have a very complex architecture where you have a ingest layer, so dedicated ingest nodes, and then a hot data nodes with very fast specs, like extremely fast SSDs, a lot of RAM, and very high spec, tons of CPUs, receiving data like crazy, serving queries like crazy. Then the data fades out, you put them in, move them with ILM or with Curator, as it was before, to your warm nodes, which are lesser specs, maybe spin and disks, cheaper hardware that you can store the data, but you don't need to query this data all the time, only when the CEO say, I want a full report. You have a master layer with master nodes there for, because the cluster state, it's probably something massive. You have a machine learning layer, alerting, and then you have coordinating nodes, which are something very interesting at the other side, because coordinating nodes will receive the query, we'll process that query, and we'll go to the data nodes to fetch the data. As the data nodes fetch that data in that shard, we'll collect that data, consolidate, and the data nodes don't have to do that work for you, for the cluster. So this is something interesting, but it needs to make sense. As I say, I see sometimes like users, yeah, I have this hot warm architecture, and it's like probably misused to death because oh, the data nodes, the hot nodes are not that big, are not that powerful, so we had to leak hot data to the warm nodes, and there you go. Architecture, that's a thing we see that happening very often. So master nodes, let's talk about the layer of master nodes. They work great in Trio. You probably don't need more than 3 master eligible nodes. But why does that happen? So until Elasticsearch 6, you had to define the minimum master nodes to hold an election. And so with 3, you can define that to 2. When you have a network partition, for example, whichever side has 2 nodes, 2 master eligible nodes, will be able to elect a master. So in this case, node 1 got to the other side of the partition. Node 1 will say, okay, I need another master node. I don't have one, so I'll stand down. While node 2 and 3 found each other and said, yeah, let's select node 3 as master node. Good. The cluster keeps running. The other side of the partition will stand down, and this will move. This setting, minimum master node, now is gone on Elasticsearch 7. Elasticsearch 7 does that for you because it was like very often misconfigured. So it does that automatically. There's no risk of split brain anymore in Elasticsearch 7. There's some tricks that you have to do there, things you have to avoid, but split brain will not happen. But we see very often now that people have 2 somethings, 2 racks, 2 zones, 2 data centers sometimes. And yeah, but you have 3 master nodes. How do you split that? You cannot put 1.5 master nodes per zone. Let's call it zone at the moment. So you're going to have to choose. You're going to have to put 2 master nodes in one of the zones. In this case, we put 2 master nodes in zone B. So I already chose, I said the zone B is my most beloved zone. So I'm going to put the 2 there. And if those 2 zones split for any reason, zone B will always run the cluster and zone A will always stand down. So regardless of what happened, you won't have a cluster if you have a split that doesn't give you 2 nodes. So what's on B, we have everything there. What we suggest there is to use a tiebreaker. So you get a 3rd zone, which is the tiebreaker zone, whatever that's what we do in the cloud. So if you get 2 availability zones, you're going to have a master node that sits in a 3rd zone. And it's there like just to tell. So I can see that all the master nodes, so I'll let him elect itself. And now with voting, master nodes that are voting only master nodes, you can have this tiebreaker zone, this very small node there that is only voting will never become the master. We just point, yeah, I can see node 3, so node 3 can be elected the master. So this would be an interesting configuration, in my opinion, to have three masternodes in 3 different zones. So from architecture, what can we use as takeaways here? So I would say scale as you need, and it needs to make sense. So as I said, you can have this huge architecture, but scale because you need. Don't have 10 nodes because you can, but have 10 nodes because you have enough data for that. You need enough processing for that. Ingest nodes are something very useful if you have, especially if you run ingest pipelines, because that takes a lot of resources from the node. If you do that in the data node, depending on the load, you might end up without the data node that's processing that. Or everything ends up filling up the heap and getting to garbage collection. So if we have dedicated ingest nodes, you can do pipeline processing there, just have the proper specs for that. The same thing on the other side, use the coordinating nodes to distribute the search, also very useful. Adaptive replica selection in the latest versions is default, but if you're not running one of the latest versions, you still can turn it on. And that means Elasticsearch will look, let's say you have a primary and a replica shard sitting obviously in 2 different nodes, and there comes a query, and Elasticsearch will see, okay, which of the 2 nodes that hold that shard is more available and will give me a best result, the fastest result. So, the replica is sitting in a very busy node, so I'm going to ask the primary or vice versa. Machine learning nodes should be dedicated nodes. Don't run machine learning jobs in the data nodes. That is killing. Machine learning uses a lot of resources. It's going to starve your data node, and your data node is going to go down or become very irresponsive and be kicked out of the cluster. So don't do that. Machine learning nodes, if you're going to learn one job, if you're going to run one job and you want to test it, cool. If you're going to run many jobs, get a machine learning node. Don't run in a data node. Like in our cloud offering, for example, we don't let you do it. You cannot start machine learning jobs if you did not enable the machine learning node, because yeah, we know what happens. Nice webinar about best practice for architecture. Take a look at that. It's really cool. Monitoring. Do monitor. I cannot stress that enough. It's like, you want to know what's happening to your cluster, you need data. You can monitor your file, all your file bits. You can monitor your log stashes. You can monitor your Kibana, every single node. You're going to have a bunch of data somewhere, and it's essential for troubleshooting. Something happened. You want to know? Look at the monitoring data. It will tell you, oh, this data was kicked out because there was a spike on CPU, and the heap garbage collection was going crazy, and this and that. There was a network issue. It was not responding anymore. What we say is, like, put a separate monitoring cluster for that. Don't do that in your production cluster. When you do that, you reduce the pressure in your production cluster, and your production cluster can do what it's meant to do, which is provide your data to your customers, being internal or not, and not be worried about also processing monitoring data. And it's available if you have an outage. So, oh yeah, my production cluster went down. Where's the monitoring node? Oh, it's in there. Okay, so bring it back without knowing what happened and try to assess your monitoring data. Okay, if you have in a separate cluster, good. You will be able to see it while you're trying to bring it back and already understand what happened. And this is included if you have one of the premium licenses. You are entitled on premises to have a single node monitoring cluster included in your license. So license-wise, doesn't cost you anything. It will cost you hardware, of course, but yeah. If you make changes to your cluster, do benchmark. Benchmark it, compare the performance. if you change configurations, if you change disks, if you add nodes, if you change your data modeling, whatever you do benchmark. And for that, we have Rally. Rally, we use it every night. So it's an internal tool that was made available to the community. Do use it. And it's an amazing tool. It's really worth it. You will see, yeah, you can do it a bunch of stuff. That's a talk by itself. We can get Daniel to make a talk here about it. Now in the flash cycle management, so talking about what I mentioned, I would say. So that was introduced in 6.7, and it's the best way to control your shards. So what you want to avoid are those tiny shards under a megabyte and under a gigabyte. You have plenty. We already did a big step, in my opinion, in that direction when we reduced the default number of shards from 5 to 1, because you would create always 5 shards, but you don't have enough data for that. So it's like, now with 1 shard is better, but you still need to control how much data you're going to put in this single shard. But my personal opinion is use a single shard, use an index with a single shard, stuff it with data, and when the limit reaches, it will move away. ILM is going to take care of that for you. You define your policy, so you define your rollover policy, you define your phases. And by rollover, it means you can have three different types of conditions. You can have a maximum size, a maximum number of documents, or a maximum age. Or you can have all of them, and whichever is reached first causes the rollover. Rollover means you're receiving data in this bucket. When a condition is met, either age or size or number of documents, this bucket moves, a new bucket's put there, and this bucket doesn't receive data anymore, a new will. So if you set, for example, maximum size to 50 gigabytes and maximum age to 1 day, you're receiving your logs there. Firebase is sending logs. Reaches 50 gigabytes, a new index is created. This one with a single shard will never go after 50 gigabytes. The problem with the shard that is larger than 50 gigabytes is that if you start having to move that around between nodes, it's going to get complicated because it's still 50 gigabytes of data. So you get 50 gigabytes, move it away, another bucket's put there, more logs come. 50 gigabytes, move it away, another bucket's put there. Oh, this one doesn't reach 50 gigabytes. I only had 40 gigabytes. Okay, 1 day later, this thing moves away. They move to the hot phase where you can specify in which type of box do you want to put it and what do you want to do with the data. Then it moves, you say, okay, stay there for 5 days and then move to the warm phase where you say, okay, move that to the warm nodes, force merge it. If you have more than 1 shard, shrink it, do whatever you want with the data. It becomes the data in the warm phase until you get to, you can have a cold phase if you want to freeze your indices or close your indices, until it gets to a point where you say, okay, after 90 days, delete the index, and it will delete the index. So you have the whole thing fitting your policies. Some companies have to hold data for 90 days. Some companies have to hold the data for 2 years. GDPR makes everybody crazy with that. So ILM helps you a lot on that. We have this webinar about ILM. I would watch it. Nice blog post explaining how to set up a hot warm code architecture in Elasticsearch using ILM. Also really good. And to close, structuring your data. Don't let your data, you need a data model. Like Elasticsearch will allow you to put whatever you want there. Good. That doesn't mean that's a good thing. From my experience, use a data model. Don't go learning your model as it goes, as new fields are being ingested, as new data comes. Have a data model. Think about what you want to achieve, how you want to structure your data, what do you want there, what you don't want. And include access in your data model. For in the premium licenses, we have something called document level security and field level security. Field level security it's great if you want to block a single field. For example, you have the IP there and GDPR says you should not show this IP to anybody. Okay, so you say nobody can see that IP. The thing is there, but nobody can see, but administrators and the CEO can see it. Okay, good. Document level security will say, okay, those documents, let's say, called project A, should not be seen by anybody that doesn't belong to project A. Good. That works. It has a performance penalty, but it works. The problem, the moment you start saying, okay, this should be seen by project A and by project G, but not by project F and project Z, the moment you start accumulating those limitations, those security rules, it doesn't scale. It gets to a point where it breaks and performance will suffer a lot with that. So if you know beforehand, you're gonna have data from project one, project A should be seen only by project A people, and project B should be seen only by project B people. So create two indices. Instead of creating limitations, create an index for project A, an index for project B, and say give project A access to that index, project B access to the other index. And you don't have to be fiddling with single document permissions. Define your mappings. If possible, don't let things fields just be created, because it might lead to, it has some side effects. It might break some stuff. So yeah, define the fields you want. I would use a non-dynamic mapping. Define expectations. What do you want as index and search throughput? And your data needs to be structured in a way that allows for that. We have Elastic Common Schema now for logs, which is already a big step on the search part. So you know the name of the thing you search. You can put all your instances together. But define your expectations, scale your cluster, and configure your cluster in a way that makes sense to do that. Know your data growth and your data retention. If you expect to have 200 gigabytes of data a day, make sure you can accommodate that. Make sure you have fast network, that you have the fastest, that you have enough nodes to do that, and that you have nodes to hold your data for 2 years or 3 years as your data retention policies require. And explore your use case. Don't be surprised by your use case. Know the use case before. Make sure you're ready for things that might come. Yeah, that's pretty much it. There's one more thing I wanted to say, is give us feedback. We're listening. Complain, comment, suggest. We have GitHub repos for each product. We have the Discuss forum. I'm pretty sure there's an email where you can send feedback. Alex can comment on that. Do give us feedback. We do listen. We do prioritize features according to the community needs. Contribute. Go to the GitHub issues. Become a contributor. Go to the Discuss forum. And if you know something, reply to it. Don't wait for the elasticsearch to reply. If you know the answer, go there and reply. And yeah, do that. Thank you very much.
Awesome. Thank you, Chris. I think there were a couple of questions on the way. One of them was, how do you guys, by Raul, how do you guys recommend to do monitoring? What especially should be monitored, and how should this be monitored?
So we have monitoring features in each of our products. So for example, for the ingestion tools, you can, I think Firebit has, you just have to toggle yes monitoring in Elasticsearch also. So you can have all the metrics from your ingestion tools there, from your Kibana and from your cluster there. And this is pretty much what I was talking about. Just go to our website, look for monitoring the stack, and you see that's what I was talking about. It gives you, yeah, everything. Basically, we use MetricBit to monitor where you hold your file bits and to monitor your nodes. So you would be able to have a lot of information. Don't know if that replies the question.
Yeah, I think the important part is that tools like Elasticsearch, they emit a lot of statistics, but all of those are just a point in time statistics. So you're unable to see trends. You can just always see what happens right now. And while this is good because it gives you an overview in that moment, you're not able to monitor trends. And this is exactly where our monitoring comes in. It stores all of this data regardless of the product in Elasticsearch, and you have nice and nifty dashboards, just not only to see if something is wrong right now, but also maybe to see if something will be wrong pretty soon. If you see more heat being consumed, these kind of things, I think that's the important part. Like just monitoring what is wrong right now might be too late if the system is not responsive. If it's responsive, it still gives you an indication, but only with getting the history on, it's super, super useful from my perspective. That's one of the things that you usually miss. Like you understand what is wrong, but you don't understand why and how this happened over time. Yeah, apart from that, I can just repeat that there is the community.elastic.co website to see for the next meetups. And I hope to see you next time, and see you soon.